In the previous video, we looked at discrete rotations, so rotations of just 90 degrees. Whereas in this video, I want to talk about a more generalized case where we can take any rotation in the two-dimensional plane. Okay, so we're going to start with a point P at coordinates x, y. Okay, and this point is an angle alpha away from the x-axis. Okay, and we're going to consider rotating that point to the new point P dash at coordinates x dash y dash. And this is an angle beta away from the point P. Okay, so it's not the angle beta all the way down to the x-axis. Okay, that's the setup here. So we can figure out a couple of things based on the fact that the radius is the same for both of these points. Okay. The first thing we should notice is that the x coordinate, okay, of point P, the x coordinate of point P is, let me get this, I'll use my blue pen. The x coordinate is this point here. Okay, so that's this side of that triangle. Okay, and because we know that the cosine of alpha, okay, is the adjacent side over the hypotenuse, then we have that the cosine of alpha is this side here, which is x, over the hypotenuse, which is r. Okay, so the cosine of alpha is x over r, and you can rearrange that to get this formula here. Okay, you can also do the same thing for this side. This side is the sine of alpha, is that side that we want, which is y divided by r, and then you can rearrange to get this. Okay, so these are the two most basic equations that we're able to derive based on the point P. Okay, we can do something similar for the point P dash. So P dash, though, we're now considering this triangle. Okay, it involves not alpha but alpha plus beta. Alpha plus beta is the relevant angle. Okay, so for very similar reasons, you can find that x dash is r cos alpha plus beta and y dash is r sine alpha plus beta. Okay, so these are our two foundation stones that we're going to build on. Okay, so if we take this equation here for the x dash coordinate and just rewrite it again, so x dash is r cosine alpha plus beta. Well, we can use the trigonometric identity, which you may or may not be familiar with, but allows us to change a cosine of two angles added together, the sum of two angles, into this identity here. Okay, so if we just multiply that out, we get r cosine alpha cosine beta minus r sine alpha sine beta. Okay, that's just from a trigonometric identity and then multiplying out the brackets. Okay, but you'll remember that r cosine alpha is the same as x. So we can replace r cosine alpha with x cosine beta. And r sine alpha is y minus y sine beta. Okay, so this is x dash. Good. We can also do the same thing for this one. So if you take our y dash coordinate here, it's equal to r sine alpha plus beta. But for the same reason, there's a trigonometric identity that will allow us to take the sum of angles and turn it into this identity here. Okay. So again, if you multiply it out, r sine alpha cosine beta plus r cosine alpha sine beta. Okay. Now you'll notice again that r sine alpha is y. So this is y cosine beta plus r cosine alpha is x, so it's x sine beta. Okay, and then just rearranging this, you get x sine beta plus y cosine beta. Okay, that's our x, sorry, that's our y dash. That's our y dash. Okay. Good. So our x coordinate gets transformed into this equation here. Okay, and our y coordinate gets transformed into this. So this is the general case for if you have a rotation of an angle beta of a point that was originally an angle alpha from the x-axis.